Yes, yes, ma'am. You're audible.
Yes, audible.
Okay, thank you so much. So before we start, can you all just post it in chat window any two terms that we discussed yesterday? Just post it in the chat window any of the two terms that we discussed in the session yesterday. Ethics, neural link, value-based ethics, NLP, natural language processing, computer vision, project cycle and ethics, okay, natural language processing, domains, statistical data, computer vision, project cycle, bioethics, yes. Okay, telepathy, bioethics and project cycle, value-based and sector-based ethics. Can somebody recollect all the 6 stages in project cycle, AI project cycle? Could you recollect the stages of AI project cycle? Whatever you remember, in 1 or 2, how many ever you remember. Deployment, yes. Problem scoping, data acquisition, data exploration, modeling. Vanita ma'am, it's not middling, modeling. Evaluation and deployment. Yes, we got everything. Okay, I'm happy to see you all remember the terms, whatever we discussed. Okay, now we will start with, okay, yeah, Subina ma'am has consolidated everything and she has posted. Thank you so much, ma'am. This is actually for grade 10 AI subject. We are actually going through second lesson today. Those who are from ICSC curriculum, I don't know how much it will be relevant to you, but we are just telling you before the session. This is a session for teachers who are teaching AI subject for grade 10 CBSE curriculum. But if you want to learn, it's fine. You can be here, no problem. Okay. So let me share my screen. Okay, so I hope you all remember yesterday I just explored. Okay, I just did a walkthrough of this portal. This is the super teacher portal. Once you get the login credential, I hope yesterday you all must have filled the form. Very soon you will get the credentials and you will be able to access all of these things, ebook for all the levels. Maybe I'll go to teacher dashboard and I'll just quickly, I will not take much time as I did yesterday, because yesterday was the first day. So we want you to know about this platform. Let me just, it is opencs.in, and okay, so you can go to select teacher and then enter the user credential and then sign in. Once you sign in, you will get access to all the books of grade 1 to 10. AI is also there. Okay, and yeah, so we will go to grade 10 now. Okay, so once you select the batch, then you will get the lesson. Okay, all the lesson plans for every lesson you will see. It will be like a in PPT format, and you can use that PPT to take classes in your classroom. We have also uploaded the digitized form of the textbook here, and then the video resources are available for each topic, and then the resources will be added, that is more additional worksheets and video resources will be added later. Okay, this is still not available now. So let me go to chapters now, and we will go to second chapter. Before that, I just want you all, yeah, so this is the second lesson we will be discussing, getting started with advanced AI modeling. This is the lesson we will be discussing. Second of grade 10 AI subject CBSE curriculum. Those who have joined late, I just want to repeat. Okay, now just see this picture. I'm sure you would have seen this picture somewhere. Are you able to recollect and tell me what is there in this picture? What do you observe in this picture? Okay, teachers who have missed to fill the form, don't worry, all the links will be shared. Okay, you need to wait. And we have also created a WhatsApp group for all the teachers, teachers who are taking AI subject, so that this platform, this group will help you to get your doubts clarified, get more information, and also you can even collaborate here. Okay, get your doubts clarified. So we have created a WhatsApp group, so everything will be posted at the end of the session. The form link to get the credentials for the super teacher platform, and the feedback link, and then the WhatsApp group link, everything will be posted. Don't worry. Okay, in the pic, all are using smartphone. Who are using smartphone? Robots are learning and humans are wasting. Okay, you're very close, Rohit sir. AI is learning. We are watching mobile. Yeah, very, very close answer, Nisha ma'am. AI work, all work through AI tools using smartphone. Vidya ma'am, the WhatsApp group link will be shared here at the end of the session. You will be able to join. So at the end of the session, all the links will be shared. Humans are becoming machines and robots are becoming humans. Very nice. Very, very close. Accessing information what AI is giving. Picture, machine adopting the human like creativity. AI is learning and humans are using it. Wow, Subina ma'am. Okay, mimic the human. Okay, yeah. Please do not share your number, post your number here. Teachers, being computer science teacher, you must be knowing that this uh, session is being streamed live on YouTube. So kindly do not post your numbers in the chat window. The link will be shared and you will be able to join the group using that link. I hope you understand. Okay. Uh, yeah, so let me show you now. Okay, I've got interesting answers. Yeah. Machines are learning and humans are hooked. I hope you all agree with that. Every click that we make on our device, every comment that we post, every activity that we do in our device, the machine is actually learning. Not only in the device, even if we are speaking, if the net is connected and then we are just talking, it is learning. Whatever you are speaking, it is listening and it is learning. Okay, now what happens when machine learns? Of course, so many good things happen when machines actually start learning, but we should also ensure that we are not completely away, because it does the learning, it does the task for us. We should not become dumb. That is the only thing. Robots are there to work for us, so humans are enjoying. Okay, yeah, nice. So let's start the lesson with this context. So this is the whole lesson. We are going to see how machines are learning. Okay, what happens when machines learn? Okay, this is the whole lesson that we will be discussing today. Let me make the screen full screen. Okay, and then make it 200. Okay, yeah. So getting started with advanced AI modeling. So yesterday also in project cycle, when we discussed AI modeling, it is where actually the training happens. Okay, training the machine happens. So when we say training, the machine is actually learning. Okay, so let's start with the context setting. As I told you yesterday, every super teacher book, every lesson in super teacher book starts with context setting, just to spark the curiosity among the students. So self-driving cars are modern day marvels. You can just go through it. Enter the car, set the destination, sit back, relax while the car takes you over wherever you want. So what all it does, it reads traffic signs, predicts speed, adjustments, changes lane smoothly. It stops at red lights, slows down for pedestrians crossing the road. It even adapts to wet or icy roads without any input from the passenger. It almost feels like magic. What makes these cars so incredibly brilliant? How these cars are working in a very, very brilliant manner. We just saw now because they are learning. How are they learning? That is what we are going to discuss in this chapter. So by the end of the chapter, these are the learning objectives. Explain the role of data in AI, contrast features and labels, compare rule-based learning and learning-based approaches, classify different machine learning techniques, summarize how ANN function. Okay, so these are all the things that we will be learning. Now, data, the fuel for AI. So we also discussed yesterday three domains of AI: statistical data, computer vision, and natural language processing. And we also discussed that data is the core for any project that you are developing. Okay, any AI project that you are developing. Now there are we are, of course, we are using smart technology on a day-to-day basis, and we don't need to think, the machines think for us. What all it does, when you are typing in the keyboard, it gives you suggestion, it predicts what word should come next. Even when you are composing email, it predicts what it will complete the sentence for you. Okay, because it is smarter, it knows what you are going to type and it finishes it for you. And facial recognition matches face by comparing data with stored images. Yes, we have face lock apps which will help us to unlock the phone, and shopping apps suggest products by analyzing data on user preferences. So how we are getting the suggestions and all, notifications, advertisements, everything with the help of data. They collect data every time you purchase. That data is stored. Okay, and with that data they are able to give suggestions for us. Okay, now yesterday we discussed the definition of artificial intelligence. If a system has the ability to mimic human intelligence, learn from data, recognize patterns, solve problem, take decisions, then we call that system as an AI system. Okay, now when we say data, okay, we just now discussed data is the core of any AI project. Now data can be collected, stored and processed. And when we say data, it can be in the form of number, text, images. For example, when a new admission comes to your school, what all we take from them, we give them admission number. So that is a number, numerical data. And then we take the name of the student, that is textual data, and we capture the photo for making the ID card. So that is image data. So like that, we have audio data or any other type of data. So when we say data, it can be in any of these forms. Now, how a car needs fuel to move, similarly, machines need data to take intelligent decisions. Okay, now how do they understand and use data? So let's break it down step by step. You can see here. Imagine you are creating an app. Okay, when you take pictures of fruit and the app identifies it for you. So for example, when you focus on apple, it says that yes, it's an apple. There is also a game. I'm sure you would have played with your students. I'm not able to recollect now. AI game which predicts the what you are drawing. Okay, I think it's AI draw or something. Okay, now how will you do that? Okay, first you will collect the details about various fruits, like name. Okay, what is the name of the fruit? Okay, these are all the names of the fruit. And for every fruit, there are some characteristics. There are some features. Like apple means it will be in red color, round shape, smooth. Orange means it will be in orange color, round shape, and bumpy. So like that.
It's quick draw, ma'am.
Ah, yeah. Thank you, ma'am. Thank you so much. Yeah, it's quick draw. So you can even ask your students to play that and see how, as they draw, it identifies what they are drawing. Or it no, I think it will give a yeah. It will make a guess as they draw. It will make a guess. Okay, so this is a small game you can ask your students to do. If time is there, maybe towards the end I will play that for you. Okay, now you can see that this is a table. It is full of facts and figures. However, machines cannot perceive data like we do. It has to be broken down into smaller parts so that the AI system can understand. Now we were talking about data, features, and all. Now when a user captures a picture, okay, what happens? It analyzes the color, shape, and texture of the fruit. Okay, as I told you, these are all the features. Okay, and once the features are identified, since we have already told, like if a particular object has these features, then this is what it is called. For example, if it is red in color, round in shapes, smooth texture, then it is called as apple. Okay, now here when you see, the name of the fruit becomes the label and all the characteristics become the feature. I will give one simple example. Now that the school has started and many new teachers would have joined the school, and we will be talking to the teachers, okay, in the staff room, like we will be asking, hey, what is the name of the new teacher who has joined? I don't know her name, but she looks tall, she's tall, long hair, big eyes. See, these are all the features you are telling. The moment you tell these features, the your colleague sitting listening all these things, all these features, okay, she will be able to make a prediction. She will immediately tell, are you talking about Kavita? So based on the features, she will be able to predict the label. So that is what it's explained here. Okay, so the features are like the inputs that you are giving. Based on these features, the system will be able to make a prediction. That is called as label. Now you have to remember that is what is given here. Now you have to remember what is a feature and what is a label depends on the problem we are solving. If we want to predict the fruit name from color, then color is the feature and fruit name is the label. For example, like the one we did. Okay, for example, I am telling all the features: tall, big eyes, long hair. So these are all the features. Whatever is the prediction, that becomes the label. But sometimes it can also be in the reverse form. If we want to predict the color from the fruit name, then the fruit name becomes the feature. So I'm telling, hey, apple is in which color? So apple becomes the feature and the red color becomes the label. So whatever is the prediction, that becomes the label, and whatever is the input, that becomes the feature. Okay, so I hope it is all clear to you. Label and feature. Can I just get quick draw? Yes. Emoji scavenger hunt. Yes. Okay. Yeah, that also can be used to. Okay. So I hope labels and features repeat, madam. Okay. So I will tell you. I will quickly give that example. So when you are talking to someone, okay, you are telling that who is the new teacher who has joined, who is very who is tall, big eyes, and long hair. So you are telling the features. The features are going as input. Your colleague will process this, and she will make the prediction. She will tell, oh, that must be Kavita that you are talking. Okay, that becomes the label. Based on these feature, a label is assigned. Okay, so the name Kavita will become the label. Okay. Now, as you can see here, now to teach the app, we provide fruit images with correct label. Yes, we provide images of fruit and we will tell, like, this is apple, this is banana. Okay, so this is called as label data. Okay, as you can see here, the image is given and it is labeled that it is apple. Okay, so for every image, there is a label which is banana. So banana is the label. Okay, and the features we just discussed now. Okay, there is a stem and it is the texture is smooth. Okay, red in color. Okay, these are all the features. But every time it is not necessary to have label data. We cannot label every time. So in many cases, data comes without predefined answers. This is called as unlabeled data. Okay, where the system only will find some pattern, okay, and it will try to group. Okay, as you can see here, this set of images, they don't have a label. Now the AI system, okay, though they are not labeled, it will know how to group it, because it will see the features automatically and then it will try to group based on the color or texture. Okay, it will group on its own. Now, once you have developed this AI system, okay, how will you train it? You will train, okay, you will train, how you will train with both unlabeled data and labeled data to help them recognize patterns and make prediction. So this is, you pick some data, okay, for example, you pick few fruits and you will use those fruits to train, okay. See, this is apple, in whichever angle you show, it has to make the prediction. So that is how you will train. So those data are called as training data. And once training is done, you will go new set of data and working properly, whether if it is able to make the predictions correctly. Okay, so that is called as testing data. I'll give you one example. For example, in suppose math teacher, we will say keep like that, and there are 10 questions in the textbook. Okay, now the teacher trains all the children using those 10 problems that are there in the textbook. So those 10 problems become the training data. And what she will do in the exam, she will pick some questions which are not there in the textbook, totally new set of data. Maybe she will go and search in the internet, or she will check in the last previous year question paper. From there, she will pick new set of question, and that she will use in the exam. Okay, that is testing data. Why she use that? To evaluate the performance of the child, whether the child has really understood or not. So that is training data and testing data. Training data will be done, okay, to make the machine learn, and testing data will be a totally new set of data to evaluate the machine's accuracy. Okay, so you can see here there is one match the following. Okay. Okay, let's not do it because we have so much to cover today. And this is the lesson which carries more weightage also. Okay, now we will be discussing about AI modeling. So yesterday also we saw, now we saw like how modeling means training the AI system and making it give the output or take a make a prediction or take a decision. So that comes under modeling. So when we talk about AI model, there are two approaches are there: rule based and learning based. So I would like to go to my PPT and I will show you. Yeah, this is the lesson, this is the overview of the entire lesson. So we have AI model. There are two approaches: rule based and learning based. So learning based is again divided into machine learning, deep learning, and machine learning is again divided into supervised, unsupervised, reinforcement. Supervised is divided into classification and regression. Unsupervised is divided into clustering and association. And when we come to deep learning here, artificial neural networks, and sorry, this is CNN, convolutional neural network. So this is the structure of the entire lesson. So basically we will be learning this, okay, in detail. So that is what is all about in this lesson. So I will go here. Now we will start from rule based approach. So the moment I say rule, you can see here the rule based approach. Data is given, the rules are given, model has to come out with the answer. Okay, so there is no scope for the model to go beyond or have some flexibility, nothing. I will give one example. Again, I'm going to take math teacher. So what math teacher will do? Data, she will give two numbers, 10 and for example now 1365 and 7. Data is given. Rule, what is the rule? Divide is the rule. Now what children will do? They just have to apply the division rule and get the answer. That's it. They don't have any scope of going beyond that or trying to explore more on that data, nothing. The rule is given. They have to just follow the rule and give the answer. This is rule based approach. Okay, now they have also here also it's given with some example. You can go through that example. Okay, but you can tell these small examples to students because they will be able to easily relate. Math teacher, math means it's all about rule. 187 comma 8, data, rule, divide is the rule. follow the division rule and getting the answer. That is rule based approach. So we will see one more scenario where it is used in real life, a food delivery app chatbot for order tracking. So you have in WhatsApp also, you can see that we will get these messages. If the user enters the order number, check if it is valid. So it will suppose we have lost the tracking, okay, the order. If we are not getting the order, then it will ask for the details, tracking details. If invalid, it will ask to re-enter. But if you type anything else, okay, if the message doesn't match any rule, then it will say, sorry, I cannot help with that. The basic chatbot that we have, okay, sometimes in WhatsApp also, or sometimes in the particular portal also, it will say, please contact customer care, because it doesn't know how to process your input beyond a particular point. Even one more simple example is the audio one. Press 1 for this, press 2 for this, press 3 for this. If you press something else, it will again start from the beginning, okay, because it doesn't know anything beyond that. So this is one example. And another examples are basic spell checker. That is also rule based. It compares what you are typing, it compares it with the dictionary, and then it will tell whether it is an error or not. Again, ATM, in ATM also you have to enter the correct pin, and if sufficient funds are there, you will get the money. Otherwise, if it will say that it is denied. That's it. Okay, so this is rule based approach. Next, we will come to learning based approach. Here, it model will learn from data. It will adapt to changes, improve its performance over time without following any fixed rule. Okay, so you can see here data is given, answers are given, it will come out with its own rules. Okay, so one example I usually used to give my students, because when I say this, ma'am, you gave example for rule based, you give example for learning based also, like that they will say. So what I will do, I will say that you go to a small child is there. So when they go for this art and craft class, data will be given. For example, sketch pens or crayons or watercolors will be given. The teacher will say, answer will be given, make a beautiful scenery. That's it. The child will apply its own rules. Okay, nobody is teaching. Some will apply blue, some will apply yellow, orange, and they will come up with their own rules, and they will come out with the beautiful scenery of their own understanding. Okay, when I say orange color and all for sky, I mean to say for sky, some will apply blue, some will apply. So here they have they can adapt to changes, improve their performance. There are no fixed rules that this is how it should be drawn. So data is given, all the papers, crayons, sketch pens, answer is given, draw a beautiful scenery. They come up with their own rules. So this is learning based approach. Now let's see one example here in real life, a smart voice assistant. Okay, so if it is rule based, then when you say play music, what it will do? It will play the music from fixed playlist. Or if you say set alarm for 7. Okay, you have to say set alarm for 7 a.m. Then it will set the alarm at 7 a.m. This is rule approach. But what happens? Teachers, please mute yourself. But what happens in learning based approach? If you say wake me up tomorrow early, then it will know, the AI system will know that what are your past pattern. Okay, if it's Sunday, usually what time you will wake up. If it's Monday, what time you will wake up. If there is a meeting scheduled in your calendar, then what time you wake up. So it will take it will analyze all these patterns, the past pattern, and then it will set the alarm on its own. So that is learning based. The more you use it, the more it will know you better, and then it will start making prediction and taking decisions for you. Okay, even if it makes a mistake, then you can correct it, and it will also remember your preference for the future. So every time, whatever you do, it will remember. Okay, so this is learning based approach. Now, some more example, YouTube recommendation. Yeah, the more you watch the YouTube, okay, so it will analyze, it will remember your watching habits. That is why it is always a good idea to delete the history, so that it won't remember your watching habits. Why? Because it will influence your decision. One example I will give: suppose you are watching a particular video favoring one particular political party. Okay, so what will happen as the time goes? It will start giving you, uploading you videos related favoring that particular political party. So you will never get to know about other parties, or there must also be other perspective on the same party, right? Political party, which you will miss out. So you will take a very biased decision. So it's always better to delete your watch history so that it will start uh, apps track workouts and suggest personalized exercise plans based on progress. Okay, now, yeah, again in the textbook there is an activity. You can ask your students to second, I just okay, you can ask your students to do this activity. You can see here there is one word which will help you to decide. A restaurant booking system assigns table based on two rules. So the rule is the keyword here, which are party of four or gets a medium table, party of six, large table. So it is rule based approach. Here you can see the word adjust. Okay, so adjust means this one keyword. Actually, there are two things that we have to focus when we teach grade 9 and 10 children. We should make them understand, and we should also, of course, make them understand all the concepts and everything. We should also train them from exam point of view. Okay, so whenever, even if they are answering this, you can tell that what is the keyword, what is that one term which helps you to find out the answer. So you can see adjust. It responds based on how you speak over time. So this adjust is a word which will tell you that it is learning based approach. Again here on a fixed timer. So again rule based. Again the word adjust. Okay, at the digital thermostat adjust. So this is all simple only. Based on the temperature, it sets the based on the weather, it sets the temperature of the room. So that is learning based. Okay, so now we will come to the next one. So we have completed rule based and learning based. So when we talk about learning based, so there are many different learning styles for our students also, right? Same way for AI also. So there are two ways it can learn: machine learning and deep learning. Okay, so we will start with machine learning. So how we learn? The same way machines also learn. We start solving simple problem, and then we start practicing more. We start understanding recognize the pattern and solve problems on our own. Over time we get better without needing any step by step guidance. That's how we also learn. So machine learning allows machines to learn in a similar way. Start with simple, understand the problem, and then be on your own. Okay, this is the same step. Okay, so machine learning is a method that allows machines to learn from data, recognize patterns, and make decisions without being explicitly programmed. For example, when we were small, we will be told like, don't touch fire. Okay, it will burn your finger. Okay, so maybe one or two times we would have touched a candle or diya. Okay, and then we would have learned. Okay, we would have understood the pattern. Okay, so we will learn, and then we will start making decision. Okay, how much of the intensity I am allowed to touch, when I should be very careful. So we take these decisions on our own. Nobody is coming and telling us explicitly, don't touch the fire on cracker, don't touch the fire on stove. Nobody is telling that. Once it is told don't touch the fire, it will be hot, we will be able to recognize the pattern, and we will be able to take care. Okay, now this is the machine learning model. Input is given. Yes, output is the label, that is the prediction. Output, here we say the prediction is the label and inputs are the feature. Okay, thank you, Vidya ma'am. Okay, so we will continue. So how the machine learning happens? Again, we give input, the machine learning model process it, and it gives output. So it takes input data, that is past or historical data, learns from it and produces output based on the pattern it finds. Now I'm not going to touch this, because this, if I take this now, it will be a little bit confusion. We will see this here. Okay, now machine learning. Now I'll take you back to the PPT. So you can see here AI models, rule-based, learning-based. So we are in learning-based. There are two types again, machine learning and deep learning. Now we are in machine learning. In machine learning, there are again three types: supervised learning, unsupervised learning, and reinforcement learning. So this is what we will be seeing now. As I told you, this is the overview of the entire lesson. Okay, so once we finish this, the lesson is done. Okay, so that's why I'm actually comparing it so you know where we are exactly. Supervised, unsupervised, and reinforcement learning. I'll go back again. Yeah, supervised learning, we will take the example again in a classroom setup. Okay, the very first time when children were very young, again the math teacher. Okay, so math teacher is teaching all the shapes: circle, square, triangle, rectangle, and all. So while the teacher is teaching, the teacher uses shapes, the teacher uses, as you can see, okay, they are the teacher will say that if it is a triangle, it has three edges and three corners, and this is how it will look, and this is called as triangle. So it is labeled. Okay, now circle, again for circle, the teacher will give the same explanation. Okay, so the teacher supervises the learning. Here the teacher is there, the teacher is giving all the guidance, providing labeled example, and checking students understanding. Okay, so the machine also learns under the guidance using labeled data. Okay, as you can see here, in supervised learning, someone is there to supervise us. Okay, that is supervised learning. Now, supervised learning is a method where a machine learns from labeled data. As I told you, the teacher tells all the features and teacher immediately labels it. Yes, this is, if it has three corners, three edges, it is a triangle. If it has four corners, four edges, and all the angles 90 degrees, then it is square. So okay, so if all the edges are equal, so the teacher will give all the features and label it that this is a square. So using correct answers to identify patterns and making prediction. So again, there is, after training, if the teacher the next day, okay, the teacher comes up with the new set of example, again the training is done. For training, the teacher drew on the board, the teacher drew show the shapes, okay, and showed some YouTube videos. But the next day, the teacher goes, these are all training data. Okay, so in the classroom, whatever the teacher does to train the child for rectangle, square, and all, that is training data. The next day, the teacher brings some cutout. Okay, she cuts some paper from home and then comes and asks the children, what is this? That is testing data. Okay, so the child has not seen that. Okay, so that is testing data, where the teacher is trying to evaluate the student understanding. Again, one more example is given, the same thing. You can go through it. So you can see here, they are all, if it is 5 gram, it is euro, 7 gram, it is dirham. And then that's how it is trained. And the model is trained here. Okay, so once it is trained with the test data, these are all test data. And later, if we show a new 1 rupee coin, okay, what it will do, it will check the feature. If it is 4 gram, okay, it weighs the coin. If it is 4 gram, it makes a prediction that it is 1 rupee. Okay, because these are all labeled data. As you can see here on the left side, these are all labeled. Again, identifying dog breeds, you can see the labeled data. Why it is labeled data? The image is there along with the name of the dog, okay, or name of the breed. Okay, so that is how, that's what is given into the system, and the machine will process it, understands what are the patterns, okay, relationship, and then the next time, if you give a new data, a test data, it will make the prediction of the breed. Okay, now this is supervised learning. As I told you, someone is there, the data is labeled, okay, it identifies the pattern, and then it makes the decision, because already it knows. So supervised learning is again divided into classification model and regression model. Let us go to this PPT. You can see here, we are in supervised learning. Sorry, this part, supervised learning divided into classification and regression. Now, what is classification and regression? So classification model. So what do you mean by classification? Grouping things, right? Even when we want to put laundry, what we will do, all whites we will separate, all dark color clothes we will separate, okay, and colored clothes we will separate. So we will group. Even in fridge, when we want to keep certain things, we arrange it in the form of groups. All dairy products in one place, all vegetables in one place, and all fruits in one place. And again, in your book bag, okay, we group things, all stationery in one place, and then all your textbooks in one place, notebooks in one place. Like that, we group, okay. This grouping is called as um, classification. So in all these cases, the goal is not to predict anything, okay. It's not going to predict anything, but to assign item to a specific category based on similarity. Some similarity should be there. Based on that similarity, they are all grouped, okay. That is what is called as classification model. So classification is a type of machine learning where a model learns from labeled data to categorize new data into predefined groups. The groups are already told, okay. You can see here the white clothes, the dark colored clothes, or dairy items, vegetables, fruits. So they are all predefined groups. We will also discuss more example, you will understand. Okay. Now to understand this better, let's take one example. Yeah. I'll give you a simple example. Okay. So when we sometimes in the class we say all girls this side, all boys this side. The moment we say that, they know how to make groups. Okay. Predefined groups. Why it is predefined? I'm telling girls group, boys group, I'm giving them. That is why it is predefined groups. Okay. To understand this better, let's look at some more example. Yeah. So yesterday also we discussed mail classification, email classification, spam or not spam. So this comes under classification. Why? Because the moment we get the email, the AI model is trained, okay, to classify whether an email is spam or not based on the content. So as I told you yesterday, it will go through the content. Based on some text in the content, it will label them as spam, or it will classify them as spam or not spam. So how it will do? Win a free iPhone now, click here. It's a spam. Okay. So these things are already trained. If text like these are there, consider it as spam. So it is already trained that way. That is why it is classifying it as spam. Meeting scheduled for 3 p.m. tomorrow. No, this is not spam. Again, it will check the next mail. Claim your lottery prize today. So if these words are there, then it is a spam. Okay. Your bank statement is ready, not a spam. Okay. So that is how understanding features and label. Feature, the content of the email is the feature, and label whether the email is spam or not. So classifying based on predefined groups. I'm just telling, classify them on spam or not spam. How it learns, you can see here. The model is trained using these labeled emails. Okay. It recognizes patterns in spam or non-spam, such as common words. As I told you, these words: claim, lottery, prize, click here, a free iPhone, discount, offer, festival offer. These words are already given to AI model and told that if you find these words, classify them as spam. That's why you might notice that some emails by mistake, it will go to spam. Okay, that can also happen. But if you again bring it to inbox, the next time it will understand, okay, now this kind of mail is not spam. It will also understand that. Okay, so this is classification model. One more, hot and cold. Okay, classifying the city based on hot and cold. So that also comes under, classifying city based on hot and cold. Okay, you can go through this example. The next comes regression model. Okay, regression model means here we are going to predict a number. We want AI model to predict something in future. Now, for example, we estimate travel time based on distance and traffic. When you book Ola, auto, or cab, it will tell the approximate time of travel. That is a regression model. That is actually, when you see that, it's a regression, because it is predicting the time when you will reach. It's predicting a number when you will reach your destination. Weather apps, what is the weather the next day? Okay, and that is number again. We estimate fuel usage based on distance travel. So again, a number. Predicting a number will come under regression model. So here you can see they are not, the goal is not to assign categories, but predict a past data. Now, this is what regression model does. It's a type of machine learning where a model learns from data to predict continuous values instead of assigning categories. It will make the prediction. I will give better example now. We will leave this. You can go through this. Predicting a car price. What will be the price of the car after 3 years? Okay, after 5 years. So based on these data, okay, it will make the prediction. Okay, you can see the prediction is a number. So it is a regression. Here also predicting the value of house. Okay, 2 bedrooms, carpet size is this, garage area is 200 square feet. Now then what will be the price of the house? Again, the prediction is a number. Then it comes under regression. Now we will see predicting whether a customer is eligible for a bank loan or not. Eligible for loan, not eligible for loan. 2 categories. So it is classification. Okay. Now the next one, predicting the weather for the next 24 hours. Again, we will be predicting the number. We will be predicting the number. Weather means it's a number, so it is regression. 1 second, just give me. I've written some example. I will give the same kind of example for both, then it will be easy for you to understand. Okay, now I want you all to open the chat window. Yeah, okay. Yeah, you have, I can see some examples. So I will give one example which you can share with your students. Okay. Now you are asking your students to stand in groups based on whether they have passed the computer science subject or all failed students, all computer science failed students this side, all computer students passed. Okay. Students who are passed in computer science this side. Now, what will you get? You will get 2 groups. Yes, this is classification. 2 groups, pass students one side, fail students one side. How will they take this decision? You tell me. How will they know that which side they have to classify themselves? Yes, it is classification. Now, my next question is, how will they classify? Yes, based on their marks. Very good, Sudharani ma'am. Based on the marks, they know how to classify. Okay, so this is classification. Now comes the next one. I will give another example for regression. Now, if you ask your, if you are going to predict the student marks based on the performance in all the FAs and XAs, you are predicting what mark the student will get in board exam. Okay, yes, it is regression because you are going to predict a number based on the performance of the child. Okay, FAs above 90s, SAs above 90. Then you know in board exam, the child will score 95. You will take some average, do some basic calculation. Yes, on internal exams, everything you will bring into picture. And then, yes, regression is always a number. And classification is always a pass or fail. Predefined group. You are telling the group name. Okay. You are telling the AI model. Okay. Classify them on pass and fail. Okay. So the group name is given. Yes. Academic performance throughout the year is assessed. Okay. Now let's go to the next part, which is unsupervised learning. Okay. So this part, we are in this part, unsupervised learning. Okay, it is divided into clustering and association. This is what we are going to see now. 1 second, I'll go. Yeah. So unsupervised learning means, as you can see here, again, the shapes are given, but no instruction is given. The teacher is not there. The teacher is giving, the teacher is simply giving all these shapes, and the students are able to group themselves based on, they are watching all these things, right? Based on the size, edge, curves, By observing the shape, the children are able to group it. Okay, the teacher never told them how to classify that shape. They figured it on their own by recognizing the pattern. Okay, so here there is no supervision from the teacher. The students themselves are discovering the patterns. Okay, now the same way mission is provided unlabeled data. Nobody is telling this is triangle, rectangle, circle. Absolutely no guidance is given. That is what is called as unsupervised learning, where a machine learns from unlabeled data, identifying patterns and structure without predefined categories or correct answer. Okay, as you have to remember this, no predefined category. Like it is not like pass this group, fail this group, squares this side, rectangles this side. No, nothing is told to them. They just group it on their own based on the patterns that they recognize. Okay, yeah, grouping animals based on similarity. Here you can see in fruits example, we saw name for each fruit, apple, orange, banana. But here you can see a bunch of images are fed into the AI model. The model will analyze each image and then it will group them. Okay. Yeah, it will group them. Okay, you can see based on the maybe cluster one. This is called as clustering. Animals with pointed ears, whiskers, and small size are considered as cats, and animals with floppy ears, larger size, and snouts. They are grouped. It doesn't know whether it is cat or dog. They just group together. They are just grouped together. Okay, again, grouping customers for targeted advertising. Yeah, we are talking about grouping customers for targeted advertising. Okay, so here you can see this is the purchase. Okay, that is done by customers in shopping app. Customer ID 101. The customer has done 15,000 purchases, and 10 shopping frequency is 10 per month, and common purchase patterns are electronics, clothing. Now again, it is the same. Okay, now this is the grouping based on the electronics that he has purchased. Okay, clothing, and these are all the things. Now let's take the example. If we want the model to find the hidden patterns, because I want the AI model to group everything on its own. Okay, it has to group. Now when we say, of course, shopping frequency is 10 and 15,000, for 15,000 rupees the customer has purchased the product. But if we notice, maybe this is the picture that we are getting, but maybe when you actually deeply analyze the data, maybe the customer has purchased these things when there was a offer. Okay, only during the offer the customer has purchased this. Okay, the next customer, one or two customer ID who has done 3,000 rupees purchases, shopping frequency 3 per month, and then groceries. Though we feel that this customer has done 3 times shopping, okay, for 3,000 rupees, if you deeply observe the data, the shopping always happens in the first week of the month. After that, he is not bothered about shopping. Okay, let's assume. Okay, that not assume. This is how it's happening. It's 3 per month, but it is not happening over the month. It is just happening in just the first week of month. And again, the last customer we will take 104,200 rupees. 12 shopping frequency is 12, fashion and accessories. But if you actually see the data, the customer 104, the customer ID 104, that person is doing shopping whenever there is a new arrival, new design, okay, unique collection. Only during this time the customer is purchasing this. So this is identifying the hidden pattern. This is not visible here, but when you actually see, okay, from the purchase pattern, okay, which is actually hidden, then this is the scenario. So what the AI model will do for targeted advertising, whenever there is a offer in electronics or clothing, it will push the advertisement to customer 101. Other times it will not show anything to this customer, because the model will know only when there is an offer, this customer is buying the product frequently. Again, for groceries, the whole month it will not trouble the customer. Okay, but in the beginning of the month, exactly the first of the month, okay, first to seventh, it will start sending, okay, all something related to groceries, okay, market value is down, like you can get less than MRP. So these kind of things, it will start advertising for this customer in the first week of month. And for this, the last one, there is a new, you need push the advertisement. So this is called as is done finding the patterns of the data. Okay, I hope you all understood that we will not get the advertisement. That is why sometimes we will think, I was planning to buy grocery and I'm getting this advertisement, or I'm getting this because first week automatically it will start sending advertisement related to groceries. Okay, so this is about unsupervised learning. So again, you can see it is divided into clustering and association model. So what do we mean by clustering? Here we will find grouping things based on similarities without any predefined category. Okay, so don't get confused with classification. Clustering is also grouping, but there is no predefined category. There is no telling like all pass students you group and all fail students you group. Nothing is happen. Some connections between them and they will form a group. Even in our mobile, we put all the shopping apps, the social media apps, we group it without actually naming them. So okay, now one example, even a music to group songs based on similarities
You
to
are not
recommend
audible
songs
properly. You are not
with any
audible.
predefined category. It will start grouping based on the mood of the song. Okay, so one example we can we can do in our classes, we can ask students, group your some pattern based on some data point that you find common among yourself. Okay, so maybe like they don't need to tell you. Okay, so they will find, because that is what is okay. You are not group, you are not telling them pass students fail students, you are not telling them. They have to find the hidden patterns, okay, some data point which is common for all of them, and they have to find group. So when I did this activity, they and later when I just asked how did you make this group, so the data point was birth month. So all June month children formed a group, April month, May month, so formed a group. So this is called as clustering without any category. They are grouping themselves based on some data as clustering. But it is not always good to have this classification without knowing a link. On what basis they are grouped, we should know, right? Groups similar data points,
You are
we
not
tell them
audible.
to I didn't ask students to form groups based on their birth month. Okay, I didn't tell the data point. Okay, without any predefined label, but sometimes we need to find the relationship between different items, grouping them. Yes, we cannot let the AI model to do the grouping completely on its own. We should know, okay, on what basis they are all grouped. So this brings us to association model. So in unsupervised learning model, supervised model, and association, unsupervised learning, we have two model, clustering model and association model. In of course, they are all grouping them into specific category, but we know what is the pattern and relationship. Okay, one example is, we know this when we go to buy butter jam, this is one combo. Again, when you buy pizza, soft drink and garlic bread is one group. Okay. And while buying school shoes, shoe polish, again, this is a one group. But there is not a name for this group. Okay. But like when you buy bread, we will buy frequent model. Okay. As you can see here, three are a combination. Laptop, mouse, laptop bag is one combo. Socks, water bottle is one. That is why whenever we buy a mobile phone, automatically also like frequently bought together. If you have used
Ramya ma'am, your voice is breaking, ma'am.
Oh,
Not able to hear.
and now is it okay, ma'am?
In between, it is breaking.
Ma'am, is it okay now?
Yes, ma'am.
Okay. I hope it will be okay. Do you want me to continue from some other place, or you want me to, or you were?
Ma'am, now it is clear, but during when you are explaining unsupervised learning, no, your voice was breaking too much. We couldn't able to.
Oh, okay. So you want me to start from unsupervised learning?
In unsupervised learning, if we can go once again with the first point, it will be better.
Yeah, unsupervised learning without any supervision, ma'am. Without any supervision, the model will, without any labeled input, the model will learn. That is unsupervised learning.
Okay, ma'am, you can continue. We'll just
Yeah.
go through. Thank
Yeah.
you.
I hope you will any problem because I've kept the door open now. But if it is there, one
See,
of you
ma'am,
unmute and immediately tell.
Still it is there, ma'am.
now again it is there, ma'am. Voice is in between, it
Still,
is okay, and then I don't know whether network issue.
just give me a second. Maybe I'll go to a different place only. Totally. Hope it is clear now.
Yes, ma'am. Now it's clear.
Yeah.
Yes, ma'am.
Yeah, I hope we shouldn't get any further problem. Okay, so where we were? Yeah, association model. Okay, so clustering is done. Where we were? Yeah, this is clustered data. So it will group, okay, based on some data point that it finds. Okay, then next is association model. So in association model, we should know the link on what basis it is grouping certain items. Okay, now certain items are frequently linked together based on past behavior. This is what an association model does. Okay, to understand this, increasing, yeah, this we saw. So how, this is how we get, right? People who purchase mobile phone, they also buy phone case and screen protector. If it finds this pattern in many customers, it knows that this is one combo. Okay, and the next time when someone else purchase mobile phone, it will show frequently bought together. So this is the suggestion it will give. And for this combo, for this bundle, it will also like provide discounts to encourage customers to buy more items. Okay, and improved personalized recommendation to match shopping patterns. Okay, so as you can see here, when we buy smartwatch, automatically earbuds and charging cable will come up in suggestion. Okay, and if this is the link that it will find between all these purchase pattern. So this is called as association model. So you can see here supervised learning, unsupervised learning, and the next one is reinforcement learning. So maybe we will take a short break. Time is 6:10 in my system. Maybe like 5 minutes break. 6:15 we will start again. Please go for a short
Okay,
break.
ma'am.
Yeah. Teachers, I hope you are all back.
Yes,
Okay.
teacher.
Yes, so we will start now. Okay, so we will start with reinforcement learning. Okay, so as the name says, okay, here the how a child usually learns, okay, even to throw a ball, okay, to play with the mother. So the child will know that how much force should be given and where to throw and all. The child will learn based on trial and error. Okay, so every time the child throws, there will be some feedback from the mother. Okay, very good, clapping and all, showing that happy face and getting excited, clapping for the child. So it is a reward the child is getting for throwing the ball properly. If the child throws somewhere else, the mother's expression will change. So that is a penalty for the child to understand, no, this is not the correct throw. Okay, so that is how the child learns. This is called as reinforcement learning through trial and error. Okay, how much force should be given, where should I throw, how should I throw, okay, what should be the like a height of my hand, where should I keep so that the ball will bounce correctly. So this is all learned by the child using trial and error method, and learning only from rewards they receive. Okay, as I told you, some kind of feedback that the child get. So this is called as reinforcement learning. AI model also learns the same way from experience, improving its performance based on feedback that it receives. When I say feedback, the feedback is in the form of reward for correct actions, penalties for mistakes. So instead of direct supervision. Okay, now, yeah, as you can see here, the image of the apple is shown. The machine is predicting cherry. Then the feedback is given as penalty. It's like wrong. Then again, the apple is shown. It is predicting apple. Then it is a reward. Then it knows that, okay, if this image is shown, then this has to be apple. So that is what is reinforcement learning. You can see the wrong one. Okay, apple is shown. It is predicting cherry. The penalty is given, which is like wrong, and then the model learns again apple is shown, it is predicting apple, so it is reward, okay, in the form of like correct, yes, it's correct, then the model is learning. So positive feedback and negative feedback. When we say positive feedback, it is reward, negative feedback is penalty. One more example is the training a robot to clean a room efficiently. So the very first time when we get the robot to our home, okay, to clean our home, okay, the vacuum cleaner, then you can see that nothing is told. Okay, the perimeter or the area of the house, okay, where everything is placed, nothing is told. The moment you leave the vacuum cleaner, it starts roaming around, okay, with the experience from the surroundings. Okay, it will understand when it hits the wall, it is when it hits an obstacle, it is a penalty, it receives a penalty, then it knows, okay, this is the edge, this is the perimeter. Then like that, as it starts moving around that environment, it will start learning, okay, where the sofa is placed, where the wall is coming. So everything it will start learning as it roams around. Okay, it understands the surrounding. So you can see the model observes the robot's action, how it moves and cleans the room. It rewards efficient cleaning, like if it removes the dust, covering all areas, avoiding obstacle means positive feedback. Negative feedback, moving in circles, hitting obstacles, wasting battery, then it will get negative feedback. Then it knows that it is not supposed to do that. Over time, the robot learns the best path and cleaning strategy to clean rooms faster and more efficiently. So it will start learning about that house on its own based on trial and error method, and also from the feedback that it receives from the AI model. Okay, so this is what is called reinforcement learning. As you can see, there is one activity here. You have to just read the action and try to say whether it is a reward or a penalty. You can ask the students to do these activities as you finish explaining. The next one is deep learning. So I'll go to my PPT so that you will know where we are now. Yeah, you can see here we have completed this part. Clustering, association, Now comes deep learning. Again, we have artificial neural network and convolutional neural network. Now, deep learning, okay. So when we talk about machine learning, we talk about simple data, less the pattern is not very complex, and it is mostly for the simple data when we use. Okay, then machine learning is suitable. Sometimes what happens, not sometimes, nowadays, the data is very huge. There are complex relationships, and it's not enough just we do with numerical data or textual data. We have images, we have speech with for large data sets. If we have to do, okay, if we want the model to make predictions and all, then we should go for deep learning approach. Okay, the machine learning and deep learning both are same, but only thing is deep learning is advanced. Machine learning works with simple data. Deep learning works with complex data where the relationships are very complex. Okay, and less number of machine learning works with less number of data. Deep learning can work with huge data set. Okay, large number of data. And deep learning can also work with images, speech, and all. It will be able to process. Now, how do we recognize faces? Okay, so we know there are multiple features that we look into: eyes, nose. That's how we remember faces. Even when they make some changes in their appearance, for example, changing the hairstyle or wearing glasses, we will still be able to identify them, okay, because of deep learning. So allows machine to function just like human brain does. It is somewhat coming closer to human brain. So deep is a method where machines learn by analyzing vast, huge amount of data, identifying complex patterns, and making decisions for complex tasks. Okay, now this is how it works: input, and this is a deep learning model. This is processing is happening here, and then the output. Okay, so identifying a bird using deep learning. So this is one example given here. You can just go through it. As you can see here, when we talk about image, okay, the model cannot process the whole image. You know, when we talk about image is made up of pixel. Okay, the smallest portion of the image. Okay, so it will analyze each pixel, and then it will be able to compare the images and predict the bird. Okay, now you can see here the image of the bird is given. This is artificial neural networks. So one type of deep learning is artificial neural network, and it will be able to identify. And if it makes the prediction wrong, the model adjusts and improves its accuracy with more training. So the learning never stops. Basically, for deep learning, the learning never stops. Now, where it will be useful: identifying objects, classifying objects in images. Okay, we will see more examples as we go through. We are talking about images. Okay, it's not the simple plain data. We are talking about images, allowing machines to understand what is present in the picture. One example I'll tell you: when you focus, we have some apps which will actually tell you your age, whether you are happy and all, and it will make prediction like that. So that and all comes under deep learning. Digit recognition: deep learning enables machines to recognize handwritten digits by learning from large data sets of examples. So whatever is handwritten can be actually converted into digitized form. Okay, so that is deep learning. Okay, you can see there is one more information. Info byte is there. The next one is, yeah, so how everything gets processed. As you can see here, our eyes capture. Once the image is captured, the image is sent to brain. There the processing of the image happens through network of neurons. Of course, we have millions of neurons in our brain. The neurons will start functioning. It compares features with past experiences to recognize what it is. And once it identifies the image, okay, based on the past experiences, the brain sends the signal telling us what we are seeing. So we are able to recollect the name of the object that we are seeing. So this is how our brain works. The same way as we told, the deep learning is very close to our functioning of our brain. So artificial neural network is a set of programs that process information just like human brain. It learns, identifies the pattern, and makes decision, and it also improves over time. Now you can see here, this is the structure. there are different layers: input layer, hidden layer, and output layer. Okay, now we will discuss each layer. Now each of these layer is further divided into smaller processing units called nodes. Okay, you can see here the circles. The circles are called as nodes. So when we come to input layer, when we talk about input layer, it is like eyes. Okay, this is the first layer. It sees the object and sends it to brain. It doesn't do anything. It receives the raw data and sends it forward. It doesn't process anything. The eyes doesn't process anything. Similarly, the input layer is the first layer. It collects the raw data, such as image, and passes it to the next layer without processing. When we say image, sometime back I was telling you, when the model, okay, when the AI system sees the image, it will not take it as a whole image like how we do. What it will do, it will break down into tiny units called pixel, the smallest building block of an image. You can see as you zoom the image, as you zoom any image, you will be able to see the pixel. Okay, so that is the smallest building block. So what it will do, it breaks down the image into smallest building blocks, and that is sent to input layer. So input layer receives these pixel values from Apple image. It doesn't process anything. It just forwards it to the next layer. What is the next layer? The next layer is the hidden layer. This is where actual processing happens, like our brain. Okay, now you can see this is, I'll show you. This is the hidden layer. The green color one is the hidden layer. Every circle that you see is node. So as you can see in the input layer, the pixels, okay, the pixel data is coming. As you know that the image is broken down into smaller parts of multiple pixel. So the pixel is coming, and once it receives the pixel, it doesn't do anything. It just sends it to the next node in the hidden layer. Now what happens in the hidden layer? That is where all the processing takes place. Each layer extracts some information, refines patterns, and then pass it, do some processing and sends it to the next node, okay, in the hidden layer only. Again, that node does some processing on the data that it has received and then sends it to the next node. So this is how it works. You can see first hidden layer detects basic shapes, shape that it will identify and pass it on to the next hidden layer. You can see there will be multiple hidden layers. Okay, you can see here, depending on how complex the model is, you can see there will be multiple hidden layers. Okay, and yeah, next, recognize color. So the next node recognize color and texture, distinguishing an apple from an orange. Again, as it goes further, more complex details are extracted from the data. That is what is happening. Now I will just quickly show one small video. You can see here, this is actually how our brain works. We would have seen in movies and all. The brain. You can see here the small electrical pulses. Okay, and each one that you see here, this is a node. Okay, and once it is done, you can see that it is connected to other node and sends it. Okay, that is how it keeps passing the data. I hope you are able to understand the same way how our brain works. Okay, here that small light that you are seeing, that is data. And these ones, okay, they are nodes, and each node is connected to other nodes, multiple nodes. Okay, the processing happens in one node, and then it sends the processed data to the next node. Further processing happens on that node, and so as it goes further, more complex details are extracted from each node. Okay, in the hidden layer, everything is happened in the hidden layer. That is like our brain. Okay, and finally comparing it to that, confirms that it is an apple. Okay, so once it is confirmed that it is an apple, then one second, yeah, I will finish this output layer. After all the processing is done, the AI makes its final decision: is this an apple? Okay, the output layer is the final layer that produces the final answer after all processing is done. So we will get an answer. Okay, the model will give us the answer that it is apple. Okay, if it is unsure, okay, if it is not very sure, it adjusts its learning and improves with more training. Again, it will start the processing, and then unless it is decided that it is an apple, the processing will happen, and once it is decided, it will tell that this is an apple. This is what happens in input layer and hidden layer. Processing will happen, output layer will give the output. Now, in the hidden layer, what exactly happens? Okay, as we know that shape, color, and all we were talking some time back. Okay, so we are also going to talk more about it, called weights and biases. What do you mean by that? There are so many features for a particular object. Okay, we were like a color, shape, size, and all. But all features don't have the same weightage. Okay, the weightage will differ for all the features. Of course, we also do that, right? For example, weights determine how much importance should be given to a particular feature. Okay, for example, if color is a strong factor in identifying an apple, the color gets the higher weightage. If shape is less important, since oranges are also round shape, then it gets the lower weight. So every feature, okay, of an object gets some weightage, okay, which will actually influence the decision of the prediction. Okay, accordingly, the weightage will differ. Some features will have more weightage, some features will have less weightage. Okay, and then biases. Biases means bias allows ANN to adjust its learning beyond just the input data. Okay, you can see here in this image, the background is not so good. Okay, but still it will adjust. Okay, it will try to make prediction even if some features are missing. That is what is called, even if something is not there or something more is there, then it will try to adjust itself. So bias means basically adjusting. Okay, lighting in the image is poor, but still ANN will recognize the apple. Okay, the next one is activation function. Okay, activation function means all unnecessary details. Okay, the distractions in the background, they are ignored. That is called as activation function. Okay, in ANN, activation function decides which information should be passed forward in the hidden layer when the processing is happened. If some information is not required, then it will not be forwarded to the next node in the hidden layer. It helps the model focus on important details and ignore unnecessary one. This is called as activation function. Okay, I hope it is clear. Now, this is how it will work. It will see what is the, okay, color is there, size is there, and texture is there. Now, which one has more weight? These are all features. Which one has more weightage? And bias, some adjustments have to be made, means that will be made. Okay, and activation function, unwanted information will be removed. Okay, that is activation function. That's how our brain also works, right? And yeah, once everything is done, okay, or taking all these into consideration, the output will be, the prediction will be made, and that will be sent to output layer. I hope it is clear, teachers. Maybe you can just go through this neural network component, brain, how the brain works and how artificial neural network works. So you can see input layer, it is related to eyes, captures raw data, that is pixel. The next is hidden layer. Okay, what happens in our brain? Process features like shape, color, texture. Here identifies patterns and refines information. And then in hidden layer, weights and biases are considered within hidden layer. Brain gives more importance to some features than others. For example, the moment we see apple, the red color only comes. The first feature is the red color. And here also in ANN, filters out unnecessary information. This is called as activation function. And then output layer, brain makes the final decision, apple. It makes the prediction, ANN makes the prediction, apple. Okay, so that is how ANN work. Okay, input layer, hidden layer, and output layer. There will be one input layer, one output layer, but multiple hidden layers, depending on the complexity of the AI system. Okay. Now, again, it is all explained, whatever around, which one has more weightage. So that they have taken. Okay, so you have to remember basically these three terms: weights, bias, and activation function. Okay, now we will see from ANN point of view. If we have to give value for that, okay, to make the prediction, to make for the AI model to make prediction, we are going to give value for that. I want to explain this separately, like I have made a PPT, so I will explain from this example. Okay, now deciding, okay, the AI model has to decide.
Ma'am, I have a question.
Yes. Yes, ma'am.
Ma'am, you said that it would adjust if the features are not okay, it doesn't match to the Apple, then it will adjust itself. Can I know how it happens?
No, ma'am, it is not that it adjusting the background and all. See, some images will be blurred, some there will be lot of distractions. So that adjustments it will make. Ma'am, I will give one example, real-time example, then you will be able to connect it better, ma'am. Now I just explained all the terms. Okay, now we will see one example. Okay, now there is an AI model, okay, which has to predict whether we will go to a concert or not. Okay, suppose you want to decide, like AI model or us, both are same only. Okay, it works like us only. So suppose you want to decide if you should go to a concert, you consider this. Okay, what are the features, inputs? Weather is a feature, whether you will first input, homework done, okay, money saved. Okay, if you have saved some money, okay, and then we have bias and then threshold. Now we will see, okay, I didn't explain threshold. Threshold is the decision point. I will give one example. Threshold means, for example, when the students are writing exam, 40 marks is the passing mark detail. That is the threshold to decide whether the student has failed or passed.
Yes.
Yeah, that is the threshold. Okay, now we will see that for weather, the weightage for this feature, weather feature, the weightage is 2. Homework done, more weightage. Of course, the homework has to be done, so that has more weightage. Whether money is there or not, that has least weightage. This is 1. The weightage 1. Now we have biased -4. What does it mean? External factors, some flexibility should be given. For example, maybe you are usually lazy to go out, so that also I am taking into consideration to allow that flexibility in the decision. And threshold is 0. When I say the threshold is 0, when I say threshold is 0, if the predicted value is more than 0, yes.
Madam, how we have taken bias as a -4?
So this is the number. This is just an example, sir.
Then that is depend on any reason, any circumstances.
So I'm giving some negative value. Yes, I'm giving a negative value because this will actually stop the person from going to the concert. Some external factors.
Ma'am, excuse me, ma'am.
That is depend on the situation.
-2?
Sorry?
-2 can we give?
Yes, any number you can give. Even the threshold according to the model that you are deciding.
Excuse me, ma'am.
Yes.
But the 4 is a value which is being seen everywhere. Even the CBSE PDFs always shows 4 only. Adding in one of the examples that is the, so is 4 a very common threshold bias that has been considered?
Okay, maybe that is taken for example, but I don't think for every scenario, for every model, for every prediction, -4 can be taken. There are so many other things also, right?
Okay, so we can consider it as any value, -3, -2, -5.
Yeah, actually, if it is given, the value will be given. If we have
Excuse me, ma'am. Excuse me, ma'am.
Yes.
Is bias should always be a negative value?
No, not necessary. It's not necessary.
Not necessary. Okay.
Thank
So
you.
bias can be positive also.
Yes. Here I have taken the example why -4, because usually you're lazy to go out. So it is stopping you from going to the concert. So the bias is -4. Basically, it is kind of some adjustment, some flexibility that I'm keeping so that I may go, even if all these conditions are met, maybe I will not go because I'm lazy to go out.
Excuse me, ma'am.
Okay, shall I proceed?
Excuse me,
Yes,
ma'am.
yes,
Can
ma'am.
you hear me?
Yes, ma'am.
So do you mean that negative number means that you are unwilling to do, and a positive number means you are willing to do? Is that anything like that with the bias? Something
Yeah,
like that?
yes. See,
Can we think of like that?
yes,
Is
see,
it
I have taken a very, very simple example. So the bias can be,
Okay.
there can be so many external factors also can be there. So some
Okay.
positives can be, see, simple thing only we are talking about. When the model is very complex, they have to take so many things into consideration. For example, in this one, if you see, when they talk about bias, it is only the background light they are talking about. It can be too dark or it can be too light also. Accordingly, the bias value will change. See, this one, see, biases allow ANN to adjust its learning beyond just the input data. So some value I'm taking. It helps ANN to make better prediction even if some features are missing. So the lighting can be poor or it can be too much light also can be there. So the bias value will change. Too much of lighting can also be there. Here it is dark, but if too much of light is there, maybe the apple will not be very clear in the photo.
But if you take negative values or positive values, then the values may change, no, ma'am.
Yes, yes. Actually, when the AI model is being trained, the values will be set according to the, even the weightage and everything will be set according to what we are expecting from the model.
Ma'am, can we keep it 6 also? -6 or maybe a +6 because I really want to go.
Okay, then you have to take, so at any cost you will go. It is like that.
Exactly. In any cost, I will go. So what
At
will be
any
my
cost,
bias?
if you will go, then there is no need to make any prediction, right?
Yes.
Excuse me, ma'am.
Yes.
How can we make this point, the term bias, very simple to make the students understand better? Weightage, anyway, based upon the importance of the factor, we can give the weightage.
Yes.
But making the students understand very simple about this term bias, how can we make it simple?
And can we say that it is an adjustment?
Yeah, that is what I told. Yeah, it is a kind of flexibility that you are giving. Every time you cannot blindly go with this feature. Though you are assigning weight for the features, some weightage you are assigning for the features, but still some kind of plus minus you have to keep that into consideration, right? So that is what is called bias. You are giving some flexibility in the AI model's decision making.
So bias is nothing but it's just external factors which may or may not affect.
Yes, exactly.
Got it.
It might
Excuse me, ma'am.
it might influence your decision or it might not.
So, ma'am,
bias is nothing but the attribute, right? That we are giving the supporting to the prediction model to make it.
Sorry, I'm sorry.
It's
Can you come
an
again?
attribute like, am I right?
Which one you are talking about?
Bias value?
Yes. Yeah, it is an attribute. Yeah, it has to be taken into consideration to give the flexibility in AI model. Like otherwise, see, even though we take these features, even though we give weightage for these features, you cannot say that. Maybe I can show one example here where everything we take as one. Yeah, you can see here, this is a feature. Okay, we will see this, the example, then you will understand. See, is it round? One. Red color? One. Smooth skin? One. Does it have a stem at the top? One. Now, all these features are met. Now, tell me what about which fruit are we talking about? Make a prediction.
It could be a cherry also. It could be a cherry also, ma'am.
Exactly. That is what I'm telling. Yeah. See, so some features will have more weightage. So it can be cherry also, it can be cherry also. Now we will see one more example. Yeah, so I will give weightage like this. For apple, if I want for apple, then which is more dominant in apple? You can see the red color. The moment we say apple, the red color has more dominance. Smooth skin has more dominance. Round, whether it is circle in shape, less weightage. Why? Because orange is also in circle shape. Many fruits are in circle shape. Does it have a stem on the top? Yes, I am giving more weightage for this. Yes, always there is a stem. We draw apple.
Weightage.
So that is how the weightage are assigned. The one that I'm showing here, this is just an example. That's it. Shall I proceed?
Ma'am, if my example says it is cherry and apple, I'm looking at apple alone, then how do I differentiate? That's exactly what I was having a doubt even before.
For that only, ma'am, we are going to do this.
Can we have one more feature then? The size of the
weight of the fruit.
Yes.
Because cherry could be in milligrams and apple could be in grams.
Yeah, grams.
You can add one more feature called weight.
Yes, of course, you can add feature and give more weightage for that.
But before I do that, how do I know that my system is not able to recognize cherry or apple? How do I know that it is not able to recognize cherry from apple?
No, this is all we are doing while training.
Okay.
While training, we will decide these factors and then we will
train the model.
Yes, train the model with these factors.
Right, ma'am, right. Okay, ma'am, got it, ma'am.
Yeah. So I hope that bias is clear, because bias means we are allowing AI model to take some, have some adjustment, some kind of flexibility in its decision making. Because there will be other external factors also. Threshold, as of now, you just know the term. While explaining, I will explain. Threshold means the decision point. Like I told you, passing mark 40. Less than 40, fail. More than 40, pass. So that is a decision point.
Excuse me, ma'am.
Yes.
Yeah, ma'am, just one question. Like, we have considered multiple features here.
Yes.
Like weather, homework done, money saved.
Yeah.
Can we have multiple bias conditions here?
Yes, that can also be given. That's what I'm telling.
For example, here I am saying lazy. Lazy is minus, but let's say I have friends to go with me.
That is a motivation for you.
That can be the positive bias.
Yeah, that can influence your decision. That will influence your decision.
Okay, fine. Thank you.
Ma'am.
Yes.
Ma'am, can you explain this bias and threshold in terms of the cherry and the apple example? How in that, yes, in this, what would be the bias and the threshold?
Ma'am, I have this example. I will explain in this example. Then you can go through that, ma'am.
Okay.
And I'll be explaining the same, because this we will be able to relate much better. So I have taken this example. Okay, I will explain this. Maybe then we will be, yes. Yes, ma'am. Okay, now we will see that how kindly mute yourself. So now we are going to see how AI model does the processing. It does some mathematical process before it takes a decision. So that is what is called as Perceptron, okay, which happens in the hidden layer. It is an algorithm that helps AI to make decision, but by combining all the inputs, that is features, weights, bias, everything it will take into consideration and it will take a decision. So that process is called as this mathematical process. Whatever I will be explaining now, it is called as Perceptron. Okay, this mathematical process. So now we will see how to solve this. Now let's assume this condition. Weather is good. Okay, so when we say, maybe I will keep like, I will stop this thing and I will show like this. I hope is this clear now, because I thought I will use this draw. Okay, now let's assume the first case. If weather is good, means 1. Okay, input is 1, and I'm representing it as 1 because AI models can work only with numbers. And homework done. Okay, good. Money saved. Yes, money is there. So 1. So what we will do, we will calculate the weighted sum. What do you mean by weighted sum? I will multiply the feature, okay, this one, along with the weightage. So it is 1 into 2 and 1 into 3 plus 1 into 1. This is called as weighted sum. 1 into 2 plus 1 into 3 plus 1 into 1, which is 2 plus 3 plus 1, which is 6. So this is a weighted sum I'm getting the node. Actually, inside the node, this is what it is doing, because it knows only the numbers. And then it will calculate the net input. How it will calculate the net input? Net input equal to weighted sum plus bias. So what is weighted sum here? We got 6. So it is 6 plus, and what is the bias value here? Minus 4. Okay, because we have taken a bias value which will demotivate us to go to a concert. So which is 6 minus 4 is 2. Okay, now this is the net input value I am getting. Now what it will do, it will compare the net input value with the threshold. So threshold I have set it as 0. So since 2 is greater than 0, that is threshold, the perceptron outputs 1, because net input is greater than threshold. If it is 1, okay, greater than threshold, the output is 1, means you will be going to the concert. That is a prediction it is making. Let's see the next scenario. If one of the inputs is 0, for example, say no money saved. Okay, so money is not there. What will happen? But you have, weather is good, you have completed the homework, but there is not money is not saved. Then what will happen? We will see. We will have to calculate the weighted sum. What will be the weighted sum?
Excuse me, ma'am.
Yes.
Ma'am, how can we decide the bias value for each and every individual example or scenario? As you said, it could be either positive or negative, and it can be any number, right?
Actually,
so if we give -2 instead of -4, the value will be different. If I give 2, the value will be different.
Yeah,
right?
actually, even if you change the threshold, it will be different.
Yes, so how can we decide that bias value for one example is this much, and for another example some other value? How can we decide that?
This is actually, for example, we have taken this. These numbers are predictions only. Okay, ma'am, I would request you, I will finish this process again. I will take the question, because once we finish this, then you will understand.
Okay, ma'am. Okay, carry
Because
on.
the continuity will go. So let me finish this perceptron process. Then we will.
Thank you.
Yeah. Surely I will answer this, but let's finish this process so that the continuity will be there. Okay, so now let's take the next one. So the first one, if all are 1, okay, all the inputs are there, then we are going to, it is predicting that we will go to concert. If one of the inputs is 0, that is money is not there. Okay, then what will be the net value? 2 plus 3. Okay, 1 into 2 plus 1 into 3 plus 0 into 1. So this becomes 0, and we will have only 2 and 3. So 2 and 3 is 5. So the net input will be 5 plus bias. Bias is -4, so we will get 1. Still it is above threshold. So definitely it will predict that you would go, because it is coming beyond the threshold. Now let's say that homework is also not done and money is also not there. Okay, in that case, what happens? Okay, here homework is not done, so this also becomes 0, and only weather is good. Okay, in that case, what we will get? 2 minus 4, which we get -2, and this net input value is compared with threshold. Okay, like every time we do. And if you see here, it is less than the threshold. -2 is less than the threshold. Now this is how perceptron uses threshold, bias, weighted sum, and net input to make the decision, yes or no decision. Now since it is less than threshold, so it will be like, it will make the prediction you will not go. This is how, in a very simple manner, the decisions are being made. The process, what's happening inside each node is happening. So actually, you please don't relate it with actual data. Okay, that is why they collect so many factors. These are all some random numbers that we have taken. When the AI developers feed in the data, they collect the actual data. Okay, they take, because we book through apps, we take it is like people who buy bread butter, will they actually go for jam also? Okay, so these predictions, okay, will this combo work or not? For that, they take the real time data and huge number of data, and they will do the data analysis, and they will set the bias, and they will set the threshold. We are talking, these numbers are just random numbers. As I told, like I can also keep the threshold different, keep the bias different. I can do anything. These are not real. We are not talking about real data. For example, see, when we know that 40 is the passing mark, okay, how we have come to know that so many years with the actual data, 40 will be correct for any students to put in minimum efforts, the basic efforts any child should put when they are in grade 10. Then that's how we decided that 40, right? The 40 didn't appear, like we like 50 also can be kept, 80 also can be kept, but why 40? So many years of data analysis, we decided that any child studying for 1 year, at least the basic knowledge, 40 marks, the basic knowledge the child should get in 1 year. That is the threshold we set based on the data we collected over so many years. That's how the CBSE has set 38 or 40 as the passing mark. I hope it is clear now. We are talking about some random values just for our understanding how inside it is happening. But when AI developers, they actually have the real time data, so much of data. They do the data analysis and then they set this. To set the bias, to set the threshold also, they might have some formula. We don't know that. This is for 10th level understanding. They have told these are the parameters that are taken into consideration by AI model to make a prediction. I hope is this clear now, ma'am? If you are asking why threshold 0, I will ask why threshold 40 for passing marks. Why BP 180 or 120? Why that is the threshold? Why based on that they decide you have low BP, less BP? Why? Why that number? Why 80 should come? Why 120 should come? Because we don't know why. But the doctors know based on they would have studied so many patients. They would have ideally for this particular age, this should be there. I hope now does it make sense?
Yes, ma'am, but only can you just explain only bias once again a little bit? It's a
Okay.
confusing factor.
Ma'am, actually, bias value is actually an emotional value. I think the value which is attached to the emotions. Because of that, emotionally, people are deciding to go or not go, right? So I think it is an emotional value.
Yeah, you can say some kind of external. See, these features will, of course, see whether homework, money will definitely influence your decision to go to a concert or not. But there can be one more influence also can be there, which can be your laziness.
And that emotional value differs from person to person, and they have taken millions of people's opinions, emotions for consideration, and based on that, they might have decided that value.
Okay, so in that case, bias value is always negative?
No,
Not
bias value could be positive also. Suppose one person wanted to go, whatever the situation comes, whatever the situation is there, a person wanted to go. So in that case, it is positive. If
Okay.
whatever situation comes, another
So
person
bias can have a multiple criteria conditions where if you are if you are not to that point, then it will comes to the positive. When it is according to the conditions what we specified is negative. Is that what you are saying, sir?
And actually, suppose if one person wanted to go, whatever the situation is there, I mean, whether he completed his homework or whether raining, heavy rain is there, he wanted to go because certain emotional attachment is there. Maybe his close friend is coming there or something like that, or he wanted to enjoy something like that. But another person is he doesn't want to go actually, whether his person, I mean, whether he complete the work or whether rain is there or not. So these are that emotional attachment. Actually, I think bias is something which
Okay. Thank you, sir.
Ma'am, I will, yeah, I think this bias is creating a lot of confusion. I will give you one more example. See, when we are actually
Ma'am,
putting
others
some
are
more
like, I think better teachers, please, others unmute yourself.
yeah, I'll unmute everyone.
Actually, ma'am, all the AI machines which are trained, the predictions.
Oh, I'm sorry. Whoever is talking, please unmute yourself.
Oh, what I mean to say, any machines when we are designing with AI,
Mhm.
this predictions will differ. The weightages will differ from machine to machine. Until a machine is designed, so the bias may also differ from machine to machine, and then the algorithms which we write when we are testing on data.
Of course, yes.
Yes,
definitely because
it's
these
not
are
be a
defined
constant
by
anywhere,
different
but it
yes,
has
no?
some ethical values we need to follow. And when we are giving examples also, there will be a contradictory always with the students. When the weightage is given for this and the weightage is given for that, the child will come up with one more solution for that. Because basically we are here just giving a model example, not exact figures.
Exactly. Yeah,
Yeah.
I will also tell. See, simple one is let's assume one example. You are correcting the paper, and you can see that the child has written all 1 mark question correctly, and then 2 mark questions correctly, and then long answers correctly. True or false, he has made some mistakes. Okay, but the child has very good handwriting. Then you will be little biased in that and give +2 for a good handwriting. We will do that or not, at least for younger class. We give
Correct,
the
correct.
we take that flexibility. We don't go just by what they have written. Okay, we just okay, the presentation is very good. We add little more marks, +2 for your presentation. So that is biased.
Yes, ma'am, correct.
And when we take actually the real things, okay, when in, for example, let's take Amazon shopping. When we are doing, okay, imagine that you are in need of AC. Yes, you are planning to buy AC. The temperature is hot. Okay, that is also one. See, let's take the features like this. Okay, you are in need of AC. Yes, so that is one. That feature is one. Temperature is hot. One. Okay, but bias can be like you not immediately buy, you will wait when there is a discount. That is some external factor, right? Maybe you will
Yes,
not
ma'am. Yes, yes.
immediately buy, you will wait. Yes, I am in need of this. These two features are one only, but I will not wait. I will wait for the discount. So that is some external factor which will influence your decision. So that's
Yes, ma'am.
how they are able to tell, okay, now what are the features? Okay, weather is bad. People will be definitely in need of AC. Let us give some offers. Let us give some discount. Okay, that will make your decision. That's how it will make a prediction. Yes, if you give some discount, then people will definitely buy. It will make a prediction. Yes, this is the right time to give discount because the value will come above the threshold. People will definitely buy the AC. Then they will give the offer.
Yes, ma'am.
Basically, it will help the business. Okay, if it gives a prediction like this, yes, if you give a discount, then people will buy. Okay, then it will help the business, okay, to design better business strategies. With this, they will say, yes, we will use this factor, biased factor, and let us increase our sales.
Yes, ma'am.
Okay, yeah, the one more last one, that is simple only. So you can see whatever I explained is given here. And yeah, the last one is convolutional neural network. This is for images. Okay, processing images and computer vision task. We will go for convolutional neural networks. Of course, there is not much covered here. Okay, ANN will consider it as a whole. Like when we want to compare ANN and CNN, ANN will take it as a whole puzzle at once, whereas CNN, convolutional neural network, it breaks the image into very, very small pieces and tries to understand it one by one. So this CNN is a better choice for image recognition. So that is what is all about. So how they are differentiating AI, ML and DL. As you can see here, artificial intelligence, it just differentiates the object. It knows that this is a tree, this is a human, this is a car. That's it. But when we come here, ML, machine learning, when we talk about machine learning, it can do little more. Okay, it identifies the human and it will also identify whether it is a boy or a girl. Okay, that much it will be able to differentiate. But when we talk about deep learning, it identifies whether it's a boy or girl. It identifies the emotion that the person is happy and smiling. It also identifies the age. Okay, based on your facial features, it analyzes your skin tone and everything, and your hair and everything it will analyze, and it will also be able to predict your age. Okay, whether you are 20 or 25, and also for this, in this only that perceptron calculations and all will happen. Okay, so let's finish with this. Okay, we have learned about AI, ML and DL. So when we talk about self-driving car in the beginning of the lesson in context setting, as you can see how it became super intelligent, because it learns multiple things through AI, okay, machine learning, deep learning, supervised learning, unsupervised learning, and reinforcement learning. So everything, all kinds of learning, like how a teacher adapts to different learning strategies to teach a child. Similarly, all learning strategies are applied for the self-driving car, and that's how it is becoming smarter and safer, and it is also continuously evolving for the future. Okay, so we can stop here. So these are all career options are also there: AI modeling, machine learning, deep learning, AI development. So you can also go through this career connect and recap. Okay, so we will stop here. Any doubts you can ask. And now feedback link will be posted for yesterday's session and today's session also. I think, I'm not sure if and WhatsApp group link is also shared. So before you leave, ensure that you fill the feedback form, join the WhatsApp group.
Ma'am, please send the
WhatsApp group link and feedback form link, both are shared.
Excuse me, ma'am. Will this material be available for us to refer now?
Ma'am, if now the YouTube link can be shared.
Okay, okay.
Yeah, you can.
Initial part, 5-10 minutes, I missed it.
Okay.
Excuse me, ma'am. Please
Yes.
explain again CNN.
Yeah, CNN is just advanced of ANN, ma'am, artificial neural network. One second. Yeah, so it does much more analysis of each pixel, okay, and process it. So it is better suitable for image recognition. As you see here, ANN is considered as a person trying to understand the whole puzzle at once. Whereas this CNN, it breaks down into smaller pieces and tries to understand it one by one, meaning more processing happens on each pixel. So the more processing means the better predictions. That's it.
Thank you, ma'am.
Swati, if you're there, can you share the YouTube link?
Yeah, ma'am, I'm sharing.
Okay.
Ma'am, kindly send the login credentials link also.
Yeah, I will post that.
Excuse me, ma'am. I have got one question.
Yes, ma'am.
Ma'am, this ANN, that weightage and all that you told about.
Yes.
Now, if such type of questions are asked in question paper, like they are given one case study type of question, the children will take any weightage or any bias. So there won't be any particular answer that this is right and this is wrong. So,
no, ma'am, if questions like this are coming, then definitely they will give all of these things, and they will give the scenario also.
okay,
Now
so
for-
they will give us the weightage or the bias or threshold or something like that.
Yes, they will give a table like this, and they will tell that what will be the perceptron, what will be the value. Okay, for this scenario, the weather is good and the homework is not done, money is there. If this is the scenario, what will be the
what will be the person?
Exactly.
Yeah. Okay, ma'am. Thank you.
These values are just assumptions only. But when AI developers, for them, they analyze the data and they will set the threshold, they will set the bias properly.
So, mom, in the exam, in board exam, they can give values and they can ask us for the prediction.
Yeah, maybe the perceptron calculation. Yeah, they can give the scenario, the case-based studies. They can give like this. They can give a table like this, and they will tell that the weather is good, homework is done, money is saved. What will be the prediction? Like how it will predict, whether it will predict that you will go to a concert or not, or they will make one or two features not met. Homework not done, money is not saved, but the weather is good. What would be the prediction of AI model?
Okay, ma'am. Got it. Thank you.
Yes, ma'am. Please join the WhatsApp group, fill the feedback form, and fill in the details for getting user credentials to access Super Teacher Portal. And if you have done that, thank you so much. We will see tomorrow again, same time, 5 o'clock.
Ma'am?
Yes?
I'm sorry, today only I joined. May I know your name?
Yeah, I'm Ramya here.
Oh, okay. Thank you.
Yes.
Excuse me, ma'am.
Yes, ma'am.
I suppose yesterday no feedback form was there, so we have to fill one feedback form for today only.
Yes, ma'am. Yeah, see the feedback form, sample copy, WhatsApp group. Yes, just fill this feedback form.
Ma'am, WhatsApp group, I didn't get it, the link.
It is there, ma'am.
I'll check.
Yeah, it's getting posted again.
Yeah, got it.
Yes. If you have filled that, you can leave.
Yeah, feedback form was filled.
Yeah, if you have any doubts, you can ask me, else you can leave.
Hello, ma'am. Hello, ma'am.
Yes, ma'am.
Ma'am, can we get for IT 402 also same like
Yes,
one
ma'am.
group, ma'am?
It is in the process, ma'am. Yeah. It's very soon
Yeah.
you will
Okay.
get it. Yeah.
Okay, ma'am. Thank you, ma'am. Thank you.
Thank you, Ramya ma'am. Session was really good.
Thank you
And
so much, Ramya ma'am. A wonderful session. Really,
thanks for your
heartfelt
effort.
thanks. Loved it.
Yes, ma'am. Very, very informative and very, very good session. I really missed yesterday's session. I was feeling so bad.
Thank you so much, Ramya ma'am. And just a doubt, can I ask now? Is it, do
please,
we
ma'am.
have
Please
time
go
to?
ahead.
Thank you so much. And can you give them insight about the project and the practicals too? If it's project oriented, it carries about 15 marks. And how to go about that? Will you cover it tomorrow or someone else is going to do
No,
that?
ma'am. How we have planned is these 3 days, we will cover the first 3 lessons of grade 10, basically for first term syllabus. And then we want to move ahead with grade 9. Okay, so grade 9 teachers are also requesting for sessions. So because for grade 9, maybe for some students it might be totally
Actually,
new
grade
for them.
9, the previous year already we have started the new syllabus, right, ma'am? So again, okay. Anyway, ma'am. Okay, fine.
No, ma'am, for new
when
teachers,
we have
basically,
New teachers will be.
yeah,
there
I
will
understand. I understand.
yeah,
Ma'am,
new
one more
teachers.
doubt, ma'am.
Yes, ma'am.
Ma'am, project, you please let us know when you're going to have a meet so that we can join in that. Regarding the project and practicals, especially.
Yes,
So
ma'am.
as internal marks is the weightage is given, and so I'm asking. And one more thing, ma'am, this bias value, especially when you explain, is really yes, we cannot predict the input. We cannot restrict the input. I do agree. எல்லாமே correct. But what I feel is it based on our output? It is just an attribute given by the programmer, right? For the purpose of making the model a successful one. That is, am I right? Is that way? It's just an attribute like the value, right? Am I right, ma'am?
Yes, making
Or
the
am I wrong?
basically to give the flexibility, ma'am, like range.
Okay.
You're actually not, don't take the it is like telling the model, don't take the decision based on only the features and its weightage. Consider these external factors also.
Okay then. Okay. But yes, what you said is right. That is, we cannot predict only this number, or we cannot restrict the input, but it can be anything. Bias should be the what is the exact term that you used? I forgot. I'm sorry.
Giving
Come
the
again.
flexibility.
Okay.
Don't restrict. So you basically telling the AI model, don't restrict your don't restrict your prediction only on features and its weightage. Consider these external factors also.
Okay, then.
When
Thank
you
you
make
so
a
much.
prediction.
Thanks for your patience. Thank you so much. Thank you so much, ma'am.
Yeah, welcome.
Signing off. Bye.
Ma'am, just before leaving, I would like to leave a small note for you. Hats off for your patience, first thing.
That is true.
So nicely, so well presented. I should really appreciate for that. Yesterday, I really missed the session. I couldn't join. But hats off to you, very nicely. Like for a small layman, how you have to explain in the same way you have explained it to us. Thanks for that. Hoping to have the same kind of sessions going ahead. I am actually a ICSE teacher, but really would love to listen to you.
Oh, thank you, ma'am. Thank you so much. These are all like you make my day.
It's no way. I mean, it's not at all there for us, but it's out of my interest. I am just learning all of these things for the CBSE curriculum. But the way you told the lesson today, it just went into my neural network today. So, yeah, thank you so much for that.
Yeah, thank you so much for your feedback, ma'am. Really great. Very happy to hear your words, Lakshmi, ma'am. Right?
Thank you so much.
And I appreciate your interest, ma'am. Though you are
I usually attend the super teacher workshops on Saturdays, Sundays, and all whenever I have the time. But just now the school reopened, we are back to back again for the schedules and all. But today only I have seen the message, so I thought, okay, this time I'm okay now. I have to listen. Let me listen what is there. But the session was too good. I have learned so much.
Oh, that's very nice, ma'am. Very happy to hear your words.
I still feel that I'm not here, or this is not a correct platform to speak about the comparison between ICSE and CBSE and all these things. But I should say CBSE curriculum is way too good compared to ICSE content that is there as of now. They are going in depth into it, each and every topic. It is much appreciable, actually.
Yes, ma'am. After this NEP 2020, lot of changes happened in the curriculum, ma'am. Truly like.
So
my ma'am, is there any possibility to get grade 12 AI curriculum? You're a great teacher. After learning the session today, no, I got an idea about the neural networks. I'm so happy to hear that CNN, ANN and all. So is there any possibility to get a grade 12 AI curriculum too?
Ma'am, we have actually started for grade 9 and 10 this year. So definitely you will get for grade 11th and 12th soon, ma'am. Like we are actually working on that.
Okay. We already started the grade 12 curriculum. So is there any possibility to get it soon or only next year?
Yeah, maybe next year only, ma'am.
Maybe next year.
Ma'am, just a small request, ma'am.
Yes, ma'am.
Yesterday, for those who missed yesterday's session, could you just give us tomorrow a 5 minute or 10 minute about these ethical frameworks? A small recap, just 5 minutes would be like the way.
Yes, ma'am. Maybe
Ma'am, it's on YouTube as
Please,
it's
please.
on YouTube actually.
Yeah, it's a new topic, so it's there on YouTube.
Yes.
Yeah, it's on YouTube, ma'am.
Okay, yesterday's session is also there on YouTube.
Ma'am,
Ma'am,
one
you-
more thing, when we
ma'am, you
start
have-
for a grade 9, where do we get this link? Because every day today also I didn't get any message. I just directly, again, it is asking for me to register, and registered and I joined. Is that so every time?
Yes, ma'am. While joining, it will ask you to register. But if now, please join the WhatsApp group, ma'am, so that we are planning to post all the links for all AI teachers. Not only that, some resources whenever we find anything related to examination, you will keep getting all the useful resources there. So join
Okay.
that WhatsApp group. That would be really helpful for you.
Because this year is the first year we started with the AI in our school. Till
Oh.
we were following IT only.
Uh-huh.
Yes.
Okay, then maybe ninth grade also, if you are.
Ninth grade, I need it, ma'am. That's the reason I'm asking. I should not miss the session.
Yeah, Monday onwards we are starting, ma'am.
Same timing, right, ma'am?
Same time, 5 to 7, 3 lessons will be completed.
Fine. Thank you so much.
Sorry, ma'am, I'm interrupting in between, but the link for class 9th will be shared in that same group
Yes,
that we have joined.
all the sessions related to AI we will share in this WhatsApp group that you have joined today.
Okay, thank you. Really, it was a wonderful session with you, ma'am.
Oh,
Even
thank you
I'm
so-
learning AI for the first time. I'm a computer science teacher.
Oh, that's great.
I teach 11th and 12th Python, but I'm very interested in learning AI. And you are really a great teacher.
Oh, thank you so much, ma'am. Thank you. Anyone else? Thank you so much, ma'am. Anyone else?
Nothing, ma'am. Thank you so much, Ramya, ma'am, for your patience handling these many teachers.
Hi, Ramya. This is Swati. I had talked yesterday also to you. Really very good explanation. Very simple, easy to understand examples that we can tell our students also. So thanks a lot because I'm teaching AI for the first time. So I was very nervous. But yesterday's and today's session has put me all my problems at ease. I can confidently teach the children. Thank you.
Wow, very nice, ma'am. Thank you so much, and all the best for your journey with AI from this academic year.
Thank you.
Thank you, madam. Same words even I have to say. You are building up our confidence. Actually, I'm also handling only 11th and 12th years at IP. I have been teaching AI from the last year, only referring to this handbook, CBS handbooks facilitators. Now, the way you are teaching and the way you have that much of patience to explain, hats off to you.
Thank you,
I was
ma'am.
really happy, and the way you have taken the class, it's really amazing. I could also grasp so many things. I jot down so many points, so many examples. It's really going to help me in my teaching. Thank you.